Well, we will go ahead and get started. So, hello and welcome to this Morpheus Tech Brief covering bare metal with Canonical MaaS. I am Martez Reed, Director of Technical Marketing with Morpheus Data. So, let's start walking through bare metal as well as with Morpheus. But to start, we'll walk through why bare metal. Certainly, there's a number of reasons and use cases that various organizations have for utilizing and leveraging bare metal as a capability within their organization. I just point out a couple of common ones that often come up: direct access to the underlying hardware. Certainly, this is becoming more common and more prevalent when we start talking about certain workload types, such as specifically AI and ML, to be able to access things like the underlying GPUs, certainly a number of others as it relates to just the need for access to direct hardware, whether that even be things like networking functionality to be able to directly access those. Performance is often another one that does come up. Certainly, depending upon the type of workload, there may be a need for that direct access to hardware to benefit from certain performance gains without having the need of the overhead of either an underlying hypervisor from that standpoint to be able to natively access that. And then finally, potentially cost savings. Some organizations, given that they may not have a need for a hypervisor, can cut out the hypervisor licensing to be able to facilitate the interaction from a bare metal server perspective or standpoint. Certainly, the industry, in terms of the cycles, has gone from previously bare metal everywhere, so to speak, to certainly virtualization coming into place, specifically server virtualization. And so that then, in many ways, for most organizations, sunset the use of bare metal in most places to be able to take advantages of the benefits of virtualization. And I think in a lot of ways, we're starting to see a bit of a shift back towards bare metal in various cases. Certainly, some of the challenges with bare metal were a forcing factor for many organizations to take advantage of in many ways, the ease of management as it relates to server virtualization. So oftentimes the challenge was just interfacing or interacting with the underlying server hardware on a regular basis was certainly difficult at times, as well as cumbersome, given the scale in which an organization might be operating from a bare metal standpoint. Certainly those that were operating at a massive scale oftentimes developed custom tooling and solutions to be able to address some of those challenges from a hardware management standpoint. And with that said, we talked about why the hardware, and so what is Canonical MaaS? So this tech brief is walking through Morpheus plus Canonical MaaS. So Canonical MaaS is a metal as a service solution from Canonical. Canonical typically being associated from an OS perspective as the creators and maintainers of Ubuntu, the Linux operating system. Certainly that's commonly where their name is heard, but MaaS is as I said, a bare metal solution that helps to address many of the challenges from a bare metal management standpoint. So what I mean by that, for those that have managed bare metal or are very familiar with bare metal solutions, there's a number of things that go into the process of being able to do things like power on or facilitate power cycling or power management for bare metal servers, as well as being able to help facilitate the deployment of images or operating systems onto those servers after they have been powered on. So Canonical MaaS provides a solution to be able to bundle those common capabilities for management of bare metal hardware, from powering on the workload to helping facilitate DHCP, PXE booting, TFTP server to be able to serve up those images, those various things that are necessary to build out an end-to-end solution from a bare metal perspective. And so now that we've talked about why bare metal and some of the reasons why it's utilized, and we have here an example of a solution in the space to be able to help facilitate that capability. Certainly Canonical MaaS provides a solution for bare metal management, but one of the things becomes, how do I expose those in a simpler or easier to consume fashion for an end consumer, whoever that might be? So that's where Morpheus comes into play to be able to essentially provide a layer on top of MaaS, similar to what Morpheus is able to do from an abstraction standpoint with hypervisors or public cloud, to be able to provide a simplified layer for consumption to end consumers. So here's just an example of how Morpheus would integrate from a canonical MaaS perspective. So a number of the things we see here, and I'll work right to left on this screen so we get an understanding. So I've got a number of servers that have been built out in my environment, and I then have what are known as rack controllers. So the items that we see in the towards the right of the screenshot, we see that there are various, in this case, 2 rack controllers. And what those represent would be addressing many of the challenges experienced with things like how to handle things like DHCP across network boundaries or network VLANs, things like that. And so MaaS, canonical MaaS, has the construct of region controllers and rack controllers. So rack controllers would sit in close proximity with the actual servers that are being provisioned, helping to provide the services such as DHCP, TFTP, things like that. As those servers, the server hardware is powered up and powered on, it has the ability to be able to locally reach, from a network standpoint, those services within that given environment. So similarly for another VLAN or another subnet, that would mirror that capability. And so certainly this would become difficult and cumbersome if Morpheus had to interact with these particular controllers. But what Morpheus is then able to do is interact with the canonical MaaS region controller. And so in this diagram, the region controller controls management and configuration of the downstream rack controllers. And so what can happen is I can have that, once again, that region controller, and then I could have, let's say, 10, 15, 20, 30 rack controllers that are under management from that region controller. And so what I'm now able to do is have Morpheus interact with the region controller from an API standpoint to be able to perform the operations and management of my bare metal estates, utilizing that single connection, so to speak, to the region controller from a MaaS perspective. And so that's how it works at a high level from an interaction standpoint. But now when we start getting into a little bit more of the detail of how does that actually work from a Morpheus perspective, and we're gonna walk through these concepts and constructs in the Canonical MaaS UI, as well as map those to constructs in the Morpheus UI from that standpoint. But a number of the things we see on this screen is understanding how the various bits and pieces fit together. So I'm going to go over a number of concepts, and then we'll take a look at them in the UI, as I said. But in this example, we have 4 servers. These 4 servers are in 2 groups. These 2 groups that they're in are associated with canonical MaaS resource pools. And so from this standpoint, I can, based upon whatever my desired delineation or classification is, I can associate those servers with a group, in this case, the resource pool, that may be based upon my environment preference. So in this case, it's development and production. And I may delineate development and production based upon certain hardware or the age of the servers or certain things that are about those particular servers that I might say, you know what, I want these to be utilized or carved off for this purpose. And then I want these other ones to be carved off for this other purpose. So following along with this example, I may decide that development is the older generation hardware. I still want to use it. I still want to leverage it, but it is the older generation hardware. And the newer generation hardware is the production workloads in my particular environment. It may have some specific hardware designations or delineation between them, but in a general case, that's what I've done for my designation or delineation. And so we also see that within my resource pools, what I can do is I can utilize the construct of tags. So there are tags within Canonical MaaS that I can use to map to service plans within the Morpheus platform. So we'll delve into that. But what I could do from the Morpheus integration standpoint is that we see here with our development and our production pools, I could map those to individual cloud integrations within the Morpheus platform, so that when a user goes to provision a workload, they can see that, you know what, I want to deploy it into the development cloud or to the production cloud, and that's going to map all the way back to the underlying hardware or resources within the Canonical MaaS platform to be able to facilitate that. So one of the things that we see also is the service plans that I've defined are 1 CPU, 4 gigs of RAM as a small, 2 CPU, 8 gigs of RAM as a medium, 4 CPU, 32 gigs of RAM as a large, just as examples. Certainly you can get much more granular and slice and dice it however you desire, but certainly it does walk through the scenario of what that would look like from the Morpheus perspective. So with that said, we're going to walk through both the Canonical MaaS UI as well as the Morpheus UI to map these constructs and understand how these building blocks work together. And so what we have here is the Canonical MaaS UI. So I deployed an Ubuntu, in this case a virtual machine, and I've installed Canonical MaaS on that virtual machine. Certainly, Canonical MaaS has documentation about how to build up or how to deploy or install the actual Canonical MaaS platform. But in this case, I do have it already deployed, and I'm simply going to leverage the Morpheus capabilities to integrate with Canonical MaaS and not walk through building out Canonical MaaS itself. So never the concepts that I talked about and constructs that I walked through in the previous section. So what I'll start with is resource pools. And so resource pools becoming an umbrella for me to be able to designate where certain servers or workloads should be placed from a quote unquote classification standpoint. And so these resource pools I can utilize for mapping into the Morpheus cloud integration. So when I go to create the Morpheus cloud integration, what I'll do is I'll specify or select a given resource pool that I want to associate. And so going back to our diagram example, that allows us to then take a Morpheus cloud and map that to a resource pool from an underlying resources perspective. And so in my case, allowing me to then designate development cloud or production cloud from an association standpoint. And so one of the things that we see is I do have a number of machines that have been added into Canonical MaaS. In my particular example, my machines are actually virtual machines, not running bare metal, but to the capabilities show how this would be done. And so when we go to add hardware in Canonical MaaS, I have a number of options that are presented and exposed here. So I would do things like specify a particular machine name for this particular workload, but a number of things of note is me specifying things like the zone. Additionally, Canonical MaaS has the construct or concept of zones, and I could do some things around that in terms of scale with the regions and region controllers. We're not going to delve too deep into that. So resource pool is one of the particular ones that we've talked about in terms of association. So I could associate the new machine that I'm onboarding with a given resource pool. I can change that after the fact as well. And so I would grab the MAC address to be able to associate this particular piece of hardware with the entry within Canonical MaaS. And so in my case, even with the VMware virtual machine example, I still am entering a MAC address because it is utilizing, in this case, DHCP as well as Pixie Boot to be able to associate that particular workload with this machine in Canonical MaaS. And so one of the things of particular importance that we talked about with bare metal is that power management. One of the challenges traditionally with bare metal is how do I control how to power on the machine and power cycle the machine and perform those various operations in a remote fashion. Certainly those that have been around the space enough know that there are a number of technologies and capabilities to be able to facilitate these various operations. And so when we go to power type for the machine, we do see a large number of those options, from things like IPMI to Intel AMT to Redfish, many of the common capabilities that are utilized for power management of physical hardware. Certainly are a number of capabilities that are actually virtual, which is a bit of a surprise as I was going through this Canonical MaaS capability to see that there are things like VMware and Proxmox and various other things. But certainly that would provide the mechanism to be able to facilitate management from a power cycling standpoint for underlying hardware. And so you would select that particular option, specify the appropriate configuration for the server that needs to be added. So in this case, I do have some existing servers that have been added into this particular MaaS installation. And so I'll just click on one and we can see some of the configuration. In this case, Canonical MaaS has done an interrogation, so to speak, what they refer to as commissioning of the underlying hardware to be able to pull back information and data about that particular system. So essentially what it does is it boots up the system, runs essentially like a microkernel to be able to perform that evaluation and that interrogation of the hardware to be able to present that into the Canonical MaaS layer. But in this case, we've got the system, we've got 8 CPUs, we got 32 gigs of RAM, got some storage. A number of things to point out, things like resource pool. So resource pool for this particular workload is production. So that's one of the key things we talked about from a Morpheus association standpoint with Canonical MaaS, is that resource pool to present those resources from the Morpheus platform in a fashion that is consistent with the desired configuration. Power type is actually VMware, since I'm actually leveraging a virtual machine. I'm interfacing with vCenter to perform power management of this particular workload. And so literally what it's going to do is it's going to power on and power off that virtual machine. In the case of real hardware, it's going to tie in or integrate with things like the IPMI and the Redfish from a configuration standpoint to facilitate those operations. One thing of particular note is tags. So we're going to touch on it here. We're going to come back to it when we start talking about service plans and associations. But I can specify tags for this particular workload. One of the things that we talked about with the service plans was that I had, in this case, BM-virtual-large as a service plan that mapped to our large virtual machines, or in this case, our large bare metal instances. So I'll click cancel. And then what we'll do is a number of the setup steps for configuration of MaaS. So certainly you would have to go through, set up the network configuration, all those bits and pieces. But in this case, I've got them set up. Now I want to tie Canonical MaaS and Morpheus together. How do I do that? So one of the first things that we would need to do is let's come to Morpheus. So I need to log into my Morpheus instance. And I will come to administration settings. So one thing to note is that if the Canonical MaaS integration does not show when you go to add a new cloud, coming to the appliances section in enabled clouds, you may need to toggle on the Canonical MaaS integration from a capability standpoint. So being able to ensure that it is configured if you do not see it. So in this case, MaaS is what we have. So make sure that's toggled on to ensure that I can actually create a Canonical MaaS cloud. So in this case, I've already got it toggled on. So I'd come to infrastructure, clouds, and I would look to create a new cloud. So I want to tie it to a Canonical MaaS cloud. And so common things that would be specified, a name for the cloud. And so now it wants the Canonical MaaS API URL as well as the API key. And so Canonical MaaS API, in this case, I'm going to simply grab it from this configuration. My configuration is utilizing HTTP. Certainly, the Canonical MaaS does support HTTPS configuration by adding SSL certificates to the actual API endpoint for Canonical MaaS. And so now I have the URL, and now I need to grab an API key for interaction with Canonical MaaS. So in this case, I'm coming to my user, and I'm going to generate a Canonical MaaS key. So going to edit Morpheus, and I'm going to copy the API key from Canonical MaaS. So now one of the things we see populate is resource pool. I'll select the release pool as production as well. And then release mode. I have a number of options for what I want to do when I release this particular workload. Canonical MaaS has these constructs from a parallel standpoint. And so whether I delete it, quick delete, or whether I release. In this case, I'm going to release because I want to do some quick testing and evaluation and just simply let that workload go to be able to be reclaimed after I've utilized it. Certainly, you can select some of the other options, certainly to be able to address things like security from a underlying hardware perspective to ensure that things like the wiping of hard drives is being done as part of the release process to ensure that before another consumer or another customer claims or allocates or deploys that particular server, that any previous data has been securely wiped, things like that. In my case, it's a lab environment, so I'm just going to do a quick release. So in this case, I'll select next. I'm going to associate it with a group within Morpheus, and then I will select complete. So it's going to go through and start initializing that cloud from a Morpheus standpoint. So now it says that it's ready. And so what I can now do is start to deploy into that particular cloud. But one of the things that I need to do is I need to have service plans available for this particular cloud, in this case, Canonical MaaS. And so go to plans and pricing and go to my provision types. And so what I've done is I have created service plans for those three flavors that I talked about earlier, the small, the medium, and the large, to associate to Canonical MaaS. So in this case, I've specified common things like the code, select the provision type. One thing in particular that is important, as we talked about, and we showed in the Canonical MaaS UI, was the tag match. So the tag match is going to match, as its name implies, on the tag from Canonical MaaS. So what do I mean by that? So let's go back into Canonical MaaS. Let's take a look at the machines. So in this case, this machine has the BM-virtual-large tag associated with it. So in this case, its hardware configuration, 8 CPU, 32 gigs of memory, matches up to what I want to expose. So in this case, it's the large. Let's take a look at the large. So that matches the 8 CPUs and the 32 gigs of RAM. So in this case, it's the BM-virtual-large. So that's how I'm handling the mapping or association of service plans to actual hardware configuration from a bare metal server perspective. And so service plan maps the tag. In this case, I'm associating tags in Canonical MaaS to the appropriate hardware configuration. In this case, I haven't added the underlying constructs of price sets and prices to this particular plan, but certainly, like many things in Morpheus, the same constructs and concepts apply to how to associate those. So I'm not going to go over those in detail, but what I will do is come to our instance types. In this case, I've created an example instance type. Nothing particularly special about this instance type, other than what I've utilized as the node type from a configuration standpoint. And really what I've done is just simply specified an image that is available from Canonical MaaS that has been synced into Morpheus as part of the configuration, and then just performed a standard operation from that standpoint. And so our layout was of the Canonical MaaS technology type. So let's take a look at those virtual images. So in this case, we'll pull in synced, and we do see these two particular images. We see Pixie Boot associated with them. So those are on the Canonical MaaS side. So in this case, what I have are two Ubuntu flavors or two Ubuntu versions within Canonical MaaS. Certainly additional operating systems could be added from a custom standpoint to add those into Canonical MaaS and expose those. But these are the two that we see that are synced into Morpheus for me to be able to select those as the underlying virtual images for the node configuration. So what I'll do is I'll come and go to provisioning, and I will select that, that example. So it's bare metal. Ubuntu 2204, bare metal. Let's go MaaS demo 1 as an example. Production environment. So in this case, I've got the one layout, and we see the various plans that I have associated or available for me to be able to provision to. So I'll provision a large, and we see our resource pool of production for me to be able to deploy into. So certainly I could say that I wanted to add another cloud and then add in my development resource pools as a capability. So that way I could select, you know what, I don't want to deploy into my production cloud. I want to deploy in the development cloud. So that allows me to do that hardware mapping from a Morpheus perspective. So I'll click next. Click next, and then I will click complete. So a couple of things are going to start happening under the covers from a configuration standpoint. So one of the things we see is Morpheus is starting to do things like deploy the server profile, starting to initiate that operation. So if we come into the Canonical MaaS side, we should see operations starting to be performed. Let's take a look at our machines. And so we see that this particular instance is now in deploying, or this particular machine is in deploying. And so it's starting to deploy that Ubuntu operating system that we told it to start deploying from the configuration perspective. And so one of the interesting things, even on the in this case, the VMware side, as our simulation of a bare metal environment, we saw that it powered on this virtual machine that's associated in Canonical MaaS. And so we see how the pieces start to fit together of Morpheus calling into Canonical MaaS to initiate the various operations from a bare metal standpoint, and then at which point Canonical MaaS is going to trigger the operations from a bare metal perspective. So doing things like turning on the underlying hardware and then starting the boot process to bootstrap that particular server as part of the workload deployment into that environment. So we see it's progressing. And so many of the constructs and capabilities are similar to other instances or workloads within the Morpheus platform. And so that provides that consistency and that abstraction of, I want to deploy a workload, whether it be the bare metal workload or a virtual machine or instance in the public cloud or even a container into my environment. And so I can do that through the Morpheus platform to be able to consume even bare metal in a cloud-like fashion to where it feels like it's on demand, readily available. I can spin it up, spin it down, and be able to access it and interact with it from the Morpheus platform standpoint. So we've walked through a number of the constructs and capabilities from an integration standpoint in which Morpheus can interact with Canonical MaaS, and then MaaS can help facilitate the configuration and deployment from a bare metal perspective. So certainly once the hooks have been put in place, I can interact with that system utilizing Morpheus operations like running automation against those particular servers after it's been bootstrapped at the OS level, similar to how it would work with virtual machines. So there's a number of capabilities that this starts to really offer, as well as a number of things that it unlocks from an organizational perspective, in which I can start to take advantage of my bare metal servers in a fashion similar to as I'm able to do with virtual machines within the Morpheus platform for deployment of workloads. Number of additional resources to get started with Morpheus if you already have it. Morpheus does have a community edition, which can be freely downloaded. It is capped at 3 clouds and 25 workloads deployed into that particular instance. We also do have the community forum to find out about things that others are doing, as well as ask questions. So that'd be discussed at morpheusdata.com. And then finally, scheduling a demo with one of our sales engineers to be able to walk through in greater detail about this feature, as well as various other features within the Morpheus platform that would be beneficial to your organization. I definitely appreciate the time and thank everyone for joining and learning more about the Morpheus and Canonical MaaS integration to be able to provision and take advantage of bare metal hardware in a cloud-like fashion. Thank you.